Hi, how's it going? I want to go back a little bit on what happens to fluids that are suspended due to low pressure or vacuum or anything that's lower than atmospheric pressure. The reason is because I made I think a rather bad mistake a little while ago, and I want to correct it. Right? So what am I talking about? You've probably all done this little experiment, and with the straw and the water. This is water that's been colored so you can see it a little better. If you dunk the straw in water and cap the end with your finger, you'll lift it up. You see you'll suspend the exact amount of water or height of water that was in that glass. And why is that? That's because there's a lower pressure here than here. Here we have atmospheric pressure, and since the water came down and how do you say, created more volume here that was there before in the straw, then pressure dropped here. So it's this difference in pressure that is suspending this water. Now, I had interesting reasoning that, this should probably work very well even for a much bigger pipe. 12-inch, 24-inch pipe. And I was telling people this quite seriously. So my idea was that build something, and maybe let's say you have a 24-inch pipe and short section, you fill it full of water, turn it upside down, the water might just stay there. It'll be lovely. It's kind of like an upside down bath. Maybe I could put fish in there, and I could walk under and stick my head in there and say hello to the fishes or something like that. So I said, wow, this is pretty cool. Maybe I should, I think it's time for me to try to make this happen. So I did a few experiments, and I quickly found out that that's not going to work. And we'll get to the reason, or what I think the reason is, very shortly. But let's review first what's going on with water that's being suspended in a tube or a pipe or something like that. So how does this come about? So we have our straw here, and we have some water here, right? So this water weighs a certain amount. We'll call that W. Now we have pressure on this side, atmospheric pressure. We'll call this atmospheric pressure, let's say, a PA. And we have, okay, now we've got to say this has to be capped, right? So your finger is doing the capping. And what will develop in here is a lower pressure, exactly because of what I said a little while ago, because the water is going to make this volume a little bigger, so pressure is going to drop in there. So we'll call this P0. So these forces here have to balance. The weight of the water has got to balance the weight of the pressure pushing it up minus the pressure pushing it down here. So how does that work out? So we know that pressure PA is going to correspond to a force A divided by the area. And the area we're talking about is this area here, the cross-sectional area. The pressure on this side is going to be, PO is going to be equal to FO divided by the area. So the weight, now of course FA then is going to be PA times A, FO is going to be PO times A, right? So the weight will have to be equal to the difference of FA minus FO, right? So FA minus FO. And we know that FA is PA times A, and the FO is PO times A. So it's PA minus PO times A, right? That's going to be equal to the weight of this liquid. So as long as PO is less than PA, and we know that's what's going to happen, I'll be able to suspend a certain amount of weight. How much weight? Well, the PA can only get as low as the value of the atmospheric pressure, and that will then determine how much weight will be able to be suspended. So why am I not able to get suspension of the liquid in a larger pipe? Well, what I believe is happening, and here's my explanation for it, is that In a small pipe, like a straw, if you look at what the liquid looks like, there's this meniscus that forms here. It's kind of like a little dome, and so this looks like, you know, this surface here. This is what's called the surface tension. This is keeping the seal around the end here, this surface tension. So as long as I got a seal, a perfect seal, the atmospheric pressure can balance the lower pressure here and suspend this amount of liquid, right? If I lose the seal, then air comes in here, and these pressures get equal and just fall down. So I believe what's happening is that the bigger this opening gets, the smaller this actual this force gets, because it's spread over a larger area. Therefore, you can't maintain this seal, and automatically you get air going into the top part. So that's the unfortunate thing about it. So try it yourself. Try it with a large Pepsi bottle or anything that you can handle in a sink, whatever, and see if you can create suspend liquid in something that's bigger than the diameter of a straw, or something like quarter inch or more. I don't think you can. Certainly you can't do it with a Pepsi type bottle or anything that's bigger than half an inch, I'd say. So that's what it is. Unfortunately, you can't make an upside down aquarium. So check it out, and see you for now. Bye bye.